Got your highlighter. Characteristic number 2. We already saw some things about horizontal asymptotes. Groups 2 and group 3 had horizontal asymptotes, but we'll also look at oblique asymptotes. So, first, our first graph here is -4 over x plus 4. This is a group 3 question. And group 3 is where the degree was larger in the denominator. I'm going to make it really simple. Everything in group 3, if you have that situation where the degree is larger than the denominator, it's really simple. Group 3 will have a horizontal asymptote at y equals 0. Because when x gets really big, it's going to get huge on the bottom, and it doesn't matter what number you have on the top. If you divide by a huge number on the bottom, it's going to get really close to 0. Right? I always use a birthday cake analogy here. It's my birthday. I've got a birthday cake. I feel like sharing, so I decide I'm going to give cake to everybody in the world. What is our population at now?
8.7 or something.
Like 8 billion, almost 9 billion. It's crazy. So I would have to take that cake and cut it into 9 billion equal pieces. Maybe I give a little bit bigger one to Stone. But how much is each person going to get? Next to nothing. So I'm like, oh, I feel bad. People got next to nothing. I'm going to buy 10 cakes. Divide those 10 cakes by 9 billion people. Right? What's going to happen? Next to nothing. Right? So I buy 9 billion people, 9 billion cakes. Right? When 9 billion people would work, but then I also give up. I like animals, and I like mosquitoes. And no, I don't actually like mosquitoes. But if I include all the insects and all the birds and all the animals, oh, now everybody gets nothing again. So this is the idea of why there's a horizontal asymptote at y equals 0. If your degree is larger in your denominator, your number on the bottom, it goes to infinity. Like we stop at 9 billion. There's a lot of numbers after 9 billion. If you want to know, start at 9 billion and start counting for like 4 days. There's a lot of numbers that you'll run into. Some you might not even have known existed. It just keeps getting bigger and bigger. Okay, so we will have a horizontal asymptote. You can add it in here at y equals 0. This one still had a non-permissible value at -4 that didn't go away. So you would also have an asymptote at x equals -4. But we're looking at when do you have horizontal and oblique asymptotes. So group 3, horizontal asymptotes. That's super easy. They go into an extra long explanation. We can ignore it. Okay. Group 2. Group 2 is with the same degree. And in group 2, this is the simple way. This one, you can do it that quick. They go into a long division technique here, which is a nice explanation. Feel free to read it. I like it, but you don't need to know that. You can just keep the simplified, and I think you'll like the simplified version. It's just the coefficients in front of the highest degree. Simplify that. 2x over x simplifies to 2. That's where your horizontal asymptote is going to be at y equals 2. Where things get interesting is with group 1. And group 1, if it doesn't simplify, Sometimes group 1, you have a factor simplify. But if you have a group 1, parabola over line with no holes is important. If you have a parabola over a line with no holes, this is the situation where you will have an oblique asymptote. And you will have to use synthetic division from polynomials unit to find it. We actually have to take the top and divide by the bottom. So if I was doing x squared divide by x plus 1, do you know that you would set up, right? If I'm dividing by x plus 1, there'd be a minus 1 out front, right? And the x squared is 1x squared, but we have to include the zeros when things are missing. There's 0 x's, and there's 0 for a constant. And how do we do synthetic division? We bring this first number down, multiply, and then add, multiply and add. This is your remainder, which you can, in this situation, ignore. Your oblique asymptote is just going to be from here, x minus 1. Even if your remainder was 1 billion, ignore it. That's where my oblique asymptote will be. And you would graph that. And again, the textbook goes into a nice extra long explanation of why it happens, but you just need to know how to find it. Nice and simple that way. So we do our synthetic division, ignore the remainder. What you're left with is your oblique asymptote. So with that, we can go to example number 2. And I'm going to go to example number 1 and steal our steps. There they are. We can have them off to the side. We're going to stroke this out, and we're actually going to graph. The question just wants to talk about horizontal asymptotes and oblique asymptotes, which is really step 3 in graphing. So I'm going to go through each of the steps per normal, and when we get to step 3, we're going to talk about the horizontal asymptotes and the oblique asymptotes tomorrow.